Okay, Mario, he's a CEO of ALCHEMCO. He's also the vice chair of IDP. He got his university degree from Brazil, went on to Europe to finish up. But the most important thing he said is he and his wife are expecting child number 5.
Well, it's going to be easy to do my presentation because after everything we learn, I think it's going to be easy to cover the few slides. So first of all, thank you very much for being here. I'm going to show a few pictures that I'm pretty sure we are all familiar with. So these are some of the issues that we see on a regular basis when we talk with DOTs. So deck cracking, efflorescence, we see some calcium leaching and some stalactites, different types of cracks, spalling, lamination, corrosion, freeze-thaw issues. And so this is something that we see on a regular basis every time when we are talking with DOTs. The point is why they happen and what can we do to avoid them from happening and giving a longer design life, a long service life to these structures. I'm going to show here a few of the points that we are very familiar with. So we have ACR, we have ASR, we have carbonation, chloride attack. So these are all the issues that we see on a regular basis on concrete. My question is, it's very interesting when we understand that the main reason why they happen, it's really 3 or 4 reasons. So if we're able to fix 3 or 4 reasons, 3 or 4 factors, we're going to be able to avoid a lot of these from happening. So these 3 or 4 factors, the first one is water. So water is often related to the premature deterioration of the concrete. So whatever we can do to remove water, that's going to help to make that structure last longer. The second thing is the calcium hydroxide. So as we were talking before, there's free calcium available in the structure, and that can be an issue later on. The chlorides, they're going to lead to corrosion, carbonation, all of that, and cracks. So it's interesting to understand that all of these issues here, if they often happen because there are these 3 or 4 items that they happen every single time, and if we can avoid them from happening, we're going to be able to help to avoid these issues. So often the solution when a situation like that happens, depending on the stage, it's either the deck replacement, so we have to build, we have to repair, or we have to build a new one. And another solution that's way less expensive and less time consuming is exactly the apply something that's going to protect that from happening. There are a lot of different solutions in the market, and we are going to talk today about the integral gel waterproofing. It's a biochemical modified silicate material. It's a complicated name, but the short name is really Integral Gel Waterproofing System. And the reason why it's integral is because all the reaction happens inside the concrete. The reason why it's a gel is because it's going to form a flexible gel. And by being flexible, the main point here is that it's going to handle thermal stress. So it's not going to be rigid like some other technologies. It's going to be forming a flexible gel. And we can see here a picture of what we're talking about, this flexible gel inside the structure. Then we have a video. There you go. So this video is exactly the type of reaction that's going to happen inside the structure. We do it on a clear cup to be easier to understand what's going to happen inside the structure. So as you can see, it's a clear liquid that we apply. And then as soon as this product is in contact with water and inside the concrete, it's going to form this white gel. So this white gel is exactly what's going to seal the pores, cracks, and capillaries. You don't see that on the surface. So you're not going to be, your structure is not going to be white or nothing like that. It's not going to change the appearance, but that's exactly the type of reaction that happens inside the structure. So here we have a few points about this technology. The first of all is that this integral gel forms a subsurface barrier. So again, all the reaction happens inside the structure, is not on the surface. So it cannot be damaged by plow trucks, by cars driving or trucks or nothing like that. All the reaction is inside the structure, so it cannot be damaged. It usually penetrates, depending on the strength of the concrete, but it usually penetrates about 3/4 of an inch. So you're going to have 3/4 of an inch of protection. And after that, one of the side effects of the waterproofing is that this material is going to increase the hardness of the concrete. So the test that we have done is that increase about 40%. So if you have a 3,500 PSI structure on this 3/4 of an inch, this area is going to increase to 5,000 PSI. On top of that, it's also going to increase the hardness of the concrete. So not only the strength, but also the hardness. The test that we have done is going to increase from 6, which is the regular 6 on the Mohs scale, which is the regular of the concrete, and then it's going to increase the hardness to 8, which is the equivalent of granite. So you're going to have a stronger concrete. And also this material is going to be able to seal the future cracks, not only the existing cracks in the concrete, and I'm going to show that later on, but also the cracks that happen after the application. This material reacts with water, so every time when you have water from rain, for example, water from rain is going to activate this material, and it's going to help to seal the new cracks. And also, this material does not trap moisture inside the structure. It allows the outgassing ability. So here we have, this is a tall booth application. So you can see that in this case, they are spraying direct. There's a van with a couple of drums there, and it's a very fast application. In this case, about 20,000 square feet per hour per person. So you don't have to close your traffic for a long time. And here we see the untreated side compared with the treated side. So the untreated, we're able to see the voids and the cracks. And then after you spray the product, the gel that we saw a couple of slides ago, that's exactly what we're seeing here on the treated side. So this material is going to form this subsurface barrier where water is not going to be able to penetrate. And the most interesting thing about this technology is really the ability to seal cracks. A lot of times when we're talking about concrete protection, we do understand that it's important to protect concrete with any type of product, because anything is better than nothing for sure. But we're not talking about how we're going to do to seal cracks. So even if your matrix, the matrix of the concrete is protect, but water is penetrating through the cracks, you're still going to have calcium leaching, you're still going to have carbonation, corrosion, because water is penetrating. So here's an interesting picture of day one. So just after the application, we see the crack, we see water, and we see it's leaking. A couple of days later, in this case, we see that we are able to see that there is some marks here, but the area is completely dry. And this is exactly the most interesting aspect of this technology. So this was exactly the presentation that we introduced to the ITD when we were showing them the technology about this ability to seal cracks in the concrete. And again, as we have seen, it's a spray-applied material. I'm going to show more videos. And this material, this technology, has the ability to seal a crack up to 2 millimeters, which is the width of a car key. So if you can put your car key inside that crack, this technology is going to be able to seal that crack so water will no longer penetrate. In addition to that, this material is also going to seal cracks that happen after the application, so of a width of 0.4 millimeters. So here we have a few points of this technology. The first of all is really the ability to seal not only existing cracks, but also cracks that happen after the application. It's a proven performance, so this technology, we have done thousands of projects in 75 countries. So it's really, we have from very cold environments like Russia and Norway to very warm environments like Italy and South America and Southeast Asia, and also here in the United States from Florida to Maine to California. So we have done projects all over, and often one of the questions is exactly, well, this product might work very well in Florida, but is it going to work in Idaho, or is it going to work in North Dakota? So often we hear a lot of these type of questions, and we have done different projects in different type of environments. It's a quick traffic reopen, so we understand that as we saw in the presentation this morning, always a hard, you always have a lot of headache when you have to close a structure. So one thing that a lot of the DOTs, they mentioned to us is that the lane closure is really a big point about this technology. We are able to resume traffic in 6 hours. So if you apply during the night, 4 a.m., 5 a.m., you're able to start your operation again. It's a long reapplication. So again, when we talk with DOTs, they want to apply something. Usually they have 20,000 bridges. So they want to apply something that they don't have to go back 2 or 3 or 5 years from now. So the reapplication of this material is going to be up to 25 years. We have done projects with more than 25 years, and they're still watertight. And this technology offers a very interesting cost-effective. So it's very cost-effective. And again, all the reaction happens inside the structure, so it cannot be damaged. It's going to densify. So after the application, you're going to have a better concrete because it's increasing the strength of the concrete and also the hardness of the concrete. It's not a toxic material. We sell this technology to water tanks, for example. So that's why we have the NSF 61, which is the potability test. So it's completely VOC-free. And again, one of my points about being a waterproofing agent, not a protectant material, is that we have dozens, actually hundreds, of water tanks and pools in areas where we have water 24/7. And about the hydrostatic pressure, we have tests up to 1,300 feet of water pressure, so 400 meters. So it's really impressive that you have 1,300 feet of water pressure with no leaking. And it's not going to change the appearance. Let's just explain why this works. And I come back to this slide because this is the single most important slide of this presentation. So if you're able to understand that these are the main issues that we see on a regular basis, and they happen because there are these 3 or 4 items here, if we are able to fix that, a lot of the issues there are not going to happen. So here we see some calcium leaching, and we see some stalactites, we see a fluorescence. So the reason why we see that is because water penetrates the concrete, then water is going to carry the salts of calcium and magnesium outside. So that's exactly what we're seeing. These 20 inches in stalactites, this is the calcium and the magnesium that water is carrying from the concrete. So we have fluorescence and carbonation, just to give a couple of examples. The very first thing that this technology is going to do when it penetrates the concrete is to react with the free calcium. So that's just like many other silicate materials. The very first reaction is this material is going to react with the free calcium. After this reaction happens, the next step is to form the flexible gel inside the structure. So this is the second step. So the first step is we are reacting with the free calcium. So you don't have the free calcium. A lot of the issues that happen in the structure, now you don't have them just because there's no free calcium available. The second thing, as these gels form, this flexible gel that handles thermal stress, you're not going to have water penetration. So as I mentioned, the tests there are up to 1,300 feet of water pressure. So the second step is you don't have water. So now inside the structure, you don't have 2 of the 4 issues. You don't have the free calcium, and you don't have new water penetrating. So when we talk about carbonation, we have the formulation here of carbonation, and carbonation is not going to happen because we are removing calcium, the free calcium available, and we are also removing water from that equation. So that's why you're not going to have carbonation. So when you go to chlorides, which is always a major concern for DOTs, chlorides, corrosion, things like that, that's not going to happen either because when these gels form, this barrier is going to block water from penetrating. So you don't have water. And if you don't have water, you're not going to have the corrosion. So from the 4 items that we saw, we were talking about water penetration, the free calcium, the chlorides, and cracks. So this technology is able to waterproof your structure, not only protect, but waterproof. This technology is able to seal cracks up to 2 millimeters. So not only the micro cracks, but we'll talk about the micro cracks as well, but cracks up to 2 millimeters, so a car key. And the material is also going to react with the free calcium. So that's really a very interesting change on for the industry. So here we have a few projects. We have this is the Louisiana application, Louisiana DOT. They did a test. In this case, they are applying with a backpack sprayer. There are multiple ways of applying, and I'm going to show different DOTs using different equipments. So this way, the application is up to 3,000 square feet per hour. So when we have a small area, the backpack sprayer is often the best equipment to use. Here's South Dakota. This application is about 40,000 square feet per hour. So that's depending on the size of the structure, this is a way better tool, a way faster equipment to use. And the application process that I'm going to show shortly is first you apply the waterproof material. This material reacts with water. So we wait this material be applied, and then we water the structure. The reason why this is important is because this material has biochemical ingredients, has enzymes, and these enzymes, they need water to be activated for the first time. So this, what the DOT truck is doing here, the South Dakota, is this is the watering process. So they already applied the waterproofing agent, and now they are applying they are activating the material, they're applying water. So we have, this technology can be applied on vertical and horizontal. In this case, Delaware DOT, they are applying to Jersey barriers. So on the vertical, the material is going to penetrate through diffusion. So it doesn't matter if it's horizontal, vertical, or if it's upside down, the material is going to penetrate the structure, the concrete. And here you see the watering phase. So they water to activate the materials inside the structure. And well, it's really, if you see a crack like that, this technology has the ability to seal. One thing that's important, you're still going to be able to see the crack. However, water is not going to be able to penetrate. The slide that we showed a few slides ago, where we were showing, day one, we were able to see the crack leaking, and then a couple of days later, the crack was completely dry. That's from underneath, so we are able to see that. But when you look on the top, you're still going to be able to see the crack. This material is not going to, magically create concrete or create cement. It's only going to waterproof with the entire crack. So the material penetrates 3/4 of an inch. However, when you have a crack, the material penetrates all the way down. So if you have a 5-inch crack, the material is going to penetrate all 5 inches. Here are a few of the concerns when DOTs are analyzing new technologies. First of all, it's just in random order, not necessarily a priority order, but one of them is the land closure. So this is a very important factor because no one wants to close their structure for a long time. So it's a very short land closure. The second is life expectancy. So DOTs want to make sure that whatever they're doing is going to last a long time. So this material is going to last up to, we have different technologies, but this one that we're talking about is going to last up to 25 years. The other question, if it's rigid or flexible. If you're designing a bridge, we know that bridge is going to have movement, so it's important to consider a technology that's capable of handling thermal stress. And this technology is flexible. It's a flexible gel. The other question is that if the material penetrates micro cracks. So in the end of the day, this material is as thin as water. The viscosity is very similar to water. So if water can penetrate that micro crack, this technology is also going to be able to penetrate that crack. The preparation, the area should be clean and dry, so usually just a pressure wash is enough. One of the limitations of this material is that the concrete should be completely dry. So that means no standing water. If we had rain, visually the area should be dry. We don't have to measure the moisture content of the structure, but visually the area should be dry. So usually we ask about 24 hours with no rain. The temperature range is 40 degrees and rising, usually from 40 to 100, the concrete temperature. And the cost of the material is low, and when we consider the life cycle cost, it's very low. So when we understand the cost of the material divided by 25 years of reapplication time, brings to a very low cost. So ALCHEMCO put together this technology specifically for the DOT about 1 year ago, and we had this technology for other markets like industrial and commercial buildings. But we put together this technology about 1 year ago, and we have done multiple, about 10 or 15 different DOTs. They have been testing this material during the last 12 months. Here, just to wrap up this presentation, a few of the projects as we were talking about, South Dakota, Illinois. One thing that you're able to see here on this, mainly on this first picture, the very first step when we are spraying this material is to flood all the cracks with the product. And that's a critical step because we want to make sure that there are enough chemicals available to seal that crack. So the very first step is we have someone with a backpack sprayer flooding all the visible cracks. Then you might have the truck, like we saw in South Dakota, applying 40,000 square feet per hour. But it's critical to target this crack, to flood the crack with the solution. Here we have New Jersey DOT, Oklahoma, Minnesota. Minnesota, this is one of the pictures from the report that we did for the ITD, where they measure the water penetration on the concrete and the water penetration when there were cracks. They also mentioned the chloride ion before the application. And for the ITD program, we do the next test that you're going to do is going to be 1 year after the application, and then 3 years, 5 years, and then 10 years after the application, exactly to be able to show the benefits of the long-term results of this technology. So Washington State DOT, Pennsylvania, Iowa, Delaware. So these were the Jersey barriers, the vertical application, as I mentioned, Ohio, Virginia. That's all. So the goal today was really to introduce, I know that a lot of you don't know yet the integral gel waterproofing technology. So if you have any questions. So from start to finish, how long it takes. After, I'm not considering the preparation. The prep is going to depend on the deck. So I'm not considering the pressure wash stage, only the application of the product. The product is trafficable after 6 hours. Depending on the technology, depending on the different products that we're going to use, it might be, you might close the bridge for 1 day, or might close the bridge for a couple of days. But in the end of the day, as you saw, the application of the main material is about from 20 to 40,000 square feet per hour. We wait usually 2 to 3 hours to be touch dry, then we start the watering process. The area is trafficable just after the watering process. That's usually 4 to 6 hours after the initial application.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.